Can you give me another method to find the constant term? Do you have an alternative method to find the same term in the expansion? Maybe you can also do it this way. That is, we can take out x squared. Alright? We can take out x squared. So the given function can be written as x squared, then 1 minus 3 over x to the power 4, right? Whole thing raised to power 10. Alright? So by index law, it will be x to the power 20, correct? X to the power 20 multiplied to 1 minus 3 over x to the power 4 to the power of 10. Alright? So here you need to expand this binomial. So you notice every term in the expansion you have to multiply by x to the power 20. Right? So to get the term which is constant, that is independent of x, you need 3 over x to the power 20. Correct? To cancel with this x to the power 20. Can you see that? You need the term that contains 3 over x to the power 20. Alright? So to get 3 over x to the power 20, therefore it is the term that is negative 3 over x to the power 4 to power 5. Correct? To power 5, so 4 times 5 will give you 20. That is the term. That is the term which contains x 3 over x to the power 20. Alright? Therefore, the term here is 1 raised to the power 10 minus 5, right? If it's 1, then you don't have to write, because 1 raised to the power 5 is still 1. Alright? Multiplied by this will give you the same term. Alright? And then the coefficient will be 10 C5. Right? Follow the power here. Alright? So this is the term in the expansion. When multiplied to x to the power 20, will give you the constant term. Do you understand? So in this form, we can also write down the constant term straight away. Alright? It will be the constant term will be equal to x to the power 20 times this term in the binomial expansion. Alright? Hence, you notice your x to the power 20, x to the power 20 cancel off. It will also give you 10 C5 multiplied to negative 3 to the power of 5. Right? Is it clear? You can use this alternative method. Alright? So in both methods, you notice we are still using the theorem. Right? We still write down any term in the expansion. Now in this method, we want the term that will give you 3 over x to the power 20. Therefore, we notice it had to be to the power of 5, right? Because 4 times 5 gives you 20. Alright? So after writing down this term, it followed by the first term. Because first term is 1. So you don't have to write 1 to the power 5. Right? 1 to the power, in fact, 10 minus 5, right? 1 to the power 5 is still 1. So the coefficient will be 10 C5. Do you understand? Alright? You're still using the same theorem. Alright? Okay, that is example 3. Okay, look at one more example. Example 4. Find the values of a and n if the first 3 terms in the expansion of 1 plus ax to the power n are 1 minus 4x plus 20 over 3 x squared. Alright? So in this case, we use the theorem, expand this until the third terms. Right? Until the third terms. First term will be 1 to the power of n. Right? 1 to the power of n, and coefficient is 1. Alright? Followed by nc1. Alright? nc1, then 1 raised to power n minus 1, which is still 1, right? So times ax to the power 1. right? The power for the second term increased by 1, right? And then nc2, right? nc2, ax to the power 2, right? Or ax squared, right? So these are the first 3 terms in the expansion of this binomial function, right? So now nc1, you follow the definition. nc1 is equal to n factorial, right? Over n minus 1 factorial times 1 factorial, right? Follow the definition you have seen earlier, is equal to this, alright? It can be simplified as n multiplied to n minus 1 factorial, correct? Your n factorial can be written as n times n minus 1 factorial over n minus 1 factorial, right? 1 factorial is 1, so we don't have to write, right? Therefore, your n minus 1 factorial cancel off, you have n, right? In other words, nc1 is n, alright? For nc2, follow the same definition, right? So we have n factorial over n minus 2 factorial times 2 factorial, right? Hence, it can be simplified as n times n minus 1, then n minus 2 factorial. We stop here because we notice there's a factor n minus 2 factorial in the denominator, alright? So whole thing divided by n minus 2 factorial, 2 factorial, okay? Therefore, n minus 2 factorial cancel off. That is nc2 is n times n minus 1 over 2, alright? Therefore, we have here 1 plus n a x, then plus n minus 1 over 2 a squared s squared, alright? So you are given the first 3 terms are 1 minus 4x plus 20 over 3 s squared. Therefore, by comparing the coefficient, you can form 2 equations in a and n, right? By comparing the coefficient of x, you have na is equal to negative 4, alright? This coefficient of x, okay? This first equation. By comparing the coefficient of x squared, alright? You have n times n minus 1 over 2a squared is equal to 20 over 3. Alright, 20 over 3. Alright? So you have one linear equation. Well, it's not really linear. Alright, na equal to negative 4 and n times n minus 1 over 2a squared equal to this. So to solve this, there are 2 ways. Alright? One method is substitution. That is, you can express a in terms of n. Alright? Substitute in. Alright? The second method is square the first equation. Square and then you divide. You notice you can get rid of a squared. Alright? So you solve simultaneously. You will find the values of a and n. Alright? So is the theorem amazing? Yes, right? It's very useful, right? In the expansion of a binomial function, right? So in the next lesson, we are going to learn the expansion with non-positive integer. All right? I think that's the end of this lesson.